All right, so in this handout, we're going to be talking about tables and graphs and how to identify and practice the A and the B value from each representation. Now, the one thing I want you to do is I want you to make a note. These are just notes that are super important. When you have a graph, I want you to make a table, but how you make a table is super important. So when you make your table, you want to make sure that your X values of your points, so whatever points you pick, they need to be in order from least to greatest and in consecutive order. And I'm going to put consecutive order from least to greatest. So they need to be in order from least to greatest. And basically you're doing it from left to right. Okay? So we're going to start with tables. We're going to go ahead and flip these over. So these are the examples. So we're going to identify the A and the B, and then we're going to identify whether it's growth or decay and write the function. So looking at number 1, first thing I'm going to do is I'm going to identify the A value. So remember, the A value is when X is 0. So I have X is 0, so therefore that means that my A value is 2. So A equals 2. So if I were to graph these points, I would see that it's crossing the y-axis at 2. And then we need to find the base. The base is the multiplier. So what do I multiply by to get to 0.4 to 2? From 2 to 10, from 10 to 50. Now, again, if you don't know what 0.4 to multiply to 2 is, then I'm going to go to the next one. So this is times 5. And then 10 times 5 gives me 50. And I can always go back and check in Desmos and say 0.4 times 5 does in fact give me 2. So my base, my multiplier is 5. Now, since my base is greater than 1, that means that my base is growth. So if I write the actual function for this, it would be y equals 2 times 5 raised to the variable x. So remember, when we write an exponential, it's a times b raised to x. A is the A is the y-intercept, and b is the base. All right, so for number 2, we're going to find the y-intercept. My y-intercept is where x is 0, so that means that my y-intercept is 8. Okay, so my A value is 8. Now I need to find my base, which is my multiplier. So what am I multiplying to get from 8 to 4, from 4 to 2, and 2 to 7? Now, if you notice, as we go down in order, we're going down in value. So a lot of students see it as dividing by 2, which is fine. There's no problem with seeing it as dividing by 2. But if you say it's being divided by 2, it's called the multiplier for a reason. We need to change the dividing by 2, and we're going to change it to multiplication. So multiplying by the reciprocal, which is 1/2. So if you see it as division, dividing by 2 is the same thing as multiplying by 1/2. So dividing by some number, we'll call the number C, is the same thing as multiplying by the reciprocal, which is 1 over C. So if we're dividing by 4, it becomes 1/4. If we're dividing by 5, it becomes 1/5. So dividing by a number is the same thing as multiplying by the reciprocal, and we have to change it to multiplication. All right, so if you notice, my base is less than 1, because 1/2 is less than 1 but greater than 0. So this is representing decay. All right, so since it's representing decay, that means that my function is going down in value because the values themselves are going down. So I'm kind of switching it up and I'm just doing the multiplication symbol and the parentheses so that you can see both of them. And that's my function. So my a is 8. My multiplier is 1/2, so it's 8 times 1/2 raised to x. All right, so for the next one, my y-intercept is when x is 0. So that means my a value, my y-intercept for the exponential, is going to be 9. All right, so then I ask myself, what am I multiplying by? How do I get from 81 to 27, from 27 to 9, from 9 to 3? So again, I'm pretty sure you're going to see it being divided by 3, which is fine. No problem. That's kind of where my brain goes as well. So, but we have to convert that. We can't leave it divided by 3. We have to change that to multiplying by 1 over 3. You cannot leave it as division. It has to be multiplication. So dividing by 3 is the same thing as multiplying by 1/3. So my base is less than 1 but greater than 0. So therefore this represents decay. And again, you can see that my values are going down, so that is representing decay. And my function is y equals 9 times 1/3 raised to x. And again, I decided to use parentheses this time. Now, in this last one, what you're going to notice is, where is my 0? I have a 1, a 2, a 3, and a 4. They're all in order. They're consecutive, but where's the 0 to find the a value? We don't have it. So if you remember when we did linear, we had to work our way backwards to find the 0. We're going to have to do the exact same thing here. We're going to have to work our way backwards and find the x value of 0. But before we can do that, we got to figure out the pattern that's happening. So I need to look and see what my base is. So how are we getting from 12 to 48, from 48 to 192, and then 192 to 768? Well, 12 times 4 is 48. 48 times 4 is 192. 192 times 4 is 768. So we're multiplying by 4. That's my base. That's my multiplier. But I now need to work backwards. So if I'm going to work backwards to get to the 0, that means instead of multiplying by 4, we're going to work backwards and we're going to divide by 4. So 12 divided by 4 gives me 3. So my a value is 3 here. Okay. So with that being said, I now am able to say that my base is greater than 1. So therefore this represents growth. So my equation is y equals 3 times 4 raised to x. All right, so hopefully all of those tables, I hope we're okay with those. So now what we're going to do is we're going to take our knowledge of tables and do graphs. So if I look at this graph, I should be able to see that it's J-shaped. It's going up. So this is going to represent growth just because of the J-shape. And we will confirm that when we find the base. So we need to find perfect points, and those perfect points need to be in consecutive order from least to greatest. So we're going to start on this side and we're going to go to the left side to the right side. So on this side, we're going to keep going, keep going. My first perfect point I come across is 0 and 3. Okay, so my first perfect point is at 0, 3. And if I go in order, I should see another one at 1 and maybe another one at 2. So I'm going to keep going. And I do see another one. I see one at 1 and 6. Okay, and if I keep going in consecutive order, I should see one at 2 and 12. Now, it's almost off the graph, but it's still there. So, other thing that I should be able to see is that my y-intercept is at 3. I can also confirm that y-intercept in the table where x is 0. So, I now am able to say, okay, my a is 3. And then I need to figure out my multiplier. Well, from 3 to 6 is times 2. 6 to times 2 is 12. So my base is 2. All right, and again, my base is greater than 1. So since my base is greater than 1, I can confirm that that is growth. So my equation is y equals 3 times 2 raised to x. All right, so number 6. If you notice for number 6, it's got the L shape. So since it's an L shape, this is going down from left to right, so this should be decay. So we're going to do the exact same thing, and we're going to find perfect points, but again, we start from the left to the right. So this time we're going to start at the top, and we're going to work our way down. So from the top, the first perfect point I come across is at -2 and 36. So if I go in order, in consecutive order, I should see at -1 and maybe at 0. All right, so I'm going to go down. So we saw one at -2 and 36. Keep going down, keep going down. We see another one at -1 and 12. And then finally, we see one at 0 and 4. So again, my y-intercept is pretty easy to see. That is at a equals 4. You can also see it in the table where x is 0. So then we need to look at the multiplier. So what is our pattern here? So to get from 36 to 12, 12 to 4. Now again, my brain automatically sees that we're dividing by 3. So if I'm dividing by 3, we can't leave it as dividing by 3. That's the same thing as multiplying by the reciprocal, which is 1/3. So my base is 1/3. And I hope we can agree that the base is greater than 1, or excuse me, less than 1, but greater than 0, which does show decay. So my actual function is y equals 4 times 1/3 raised to x. So again, my a value was 4, and my base is 1/3, and that's raised to x. That's my exponential function. All right, so we go to number 7. We can see that that's got a J shape. That's going up from left to right, so this is going to be growth. So we're going to start on the left, and this time we're going to work our way up because it's going up from left to right. And we're going to find perfect points. Now the first perfect point I see is 0 and 5. So we should see another one at 1. And honestly, we could stop right here if we wanted to. We should be able to see that I have a y-intercept at 5. So we know the a value is 1. The a value is 5. And what pattern do we see? Well, to get from 5 to 15, I'm multiplying by 3. So I should be able to say my base is 3 just by looking at that one. However, I do have another perfect point. If I go back, I have another perfect point at 2 and 45. So I also can see that from 15 times 3, that also gives me 45. So that is in fact showing growth because my base is greater than 1. So we have y equals 5 times 3 raised to x. All right, and our last graph that we have a graph that has got the L shape. So L shape here. So since it's going down from left to right, this should be decay. So we're going to start at the top this time and work our way down, and we're going to find perfect points. So my first perfect point that I see is at -2 and 180. So I should have another one at -1. So if I go to -1, I have one at 60. And then again, I have another one at 0 and 20. So my y-intercept I can see is at 20. I can also see that in the table. So my a value is 20 for my y-intercept. And then over here, to get from 180 to 60 and then 60 to 20, again, my brain automatically sees dividing by 3. But we cannot leave it as division. We have to turn it into multiplication. So we're going to say it's multiplying by 1/3. So my base is less than 1 and greater than 0, so it is showing decay. And my final function for this is going to be 20 times 1/3 raised to x. So just remember, if you see division, that's fine, but you've got to turn it into multiplication. So couple, like we did here, dividing by 3, we turned it into multiplying by 1/2. That is, if you don't turn it in and convert it, then it's not going to be right. You have to turn your division into multiplication. My A value, my y-intercept, is where it crosses the x-axis, or where x is 0 in the table. And then if it's L-shaped, it's decay. If it's J-shaped, then it's growth.